Hello dear students, welcome you all once again to the NEET 10 Game Changer program by Sri Chaitanya. So for the last a couple of days we have been discussing the questions from the previous NEET examinations and thus also ensuring that the theory part is also discussed. And I could see that there is a fabulous response from the students as well. So now I would discuss some more questions and related theory, and I would anticipate the same from you all, like you have been giving fabulous response over the screen with the questions that are being displayed. We would anticipate the same. So let's get started without wasting much of your time. Let's see the question number 1 of the day. That's from the general organic chemistry or practical organic chemistry, which we usually ignore, isn't it? When it comes to especially the stoichiometry part, that is the quantitative approach to what you call the estimation of a particular compound or the elemental analysis, we usually tend to ignore that part. But let me tell you, occasionally the questions had been asked on the determination of the percentage of halogen, sulfur, nitrogen. This has been the repeated trend. Some of the analysis is being repeatedly asked. So in this question you can see that percentage of nitrogen is being asked. Nitrogen is estimated by following two processes, isn't it? One is called as 2-mass method, the other is Geldahl method. I would like to give you the formula related to both, so that if question strikes this here by chance on Geldahl method, what is that other method called as beta? Geldahl method, right? So first let me give you that formula and then I will solve this question for you, right? So nitrogen is estimated, that is mass percentage of nitrogen can be calculated by using, I said, two concepts. Number one, Geldahl method. Let me write that for you. Most of the students ignore this. Alright, in this method we determine the percentage, the mass percentage of the nitrogen in the given compound, isn't it? What is the formula which is being used? This concept is purely based on the titration with the H2SO4 solution. So the data which is given would be related to the normality and volume of H2SO4. Alright. So in Geldahl method we find out the percentage of nitrogen by using a very simple formula. That formula would be normality of sulfuric acid, which is required for the complete neutralization of the ammonia which is formed during the process, into its volume in liter. In liter you need to take, for example, if you are taking in milliliter, you have to divide that with 1000, isn't it? So normality into volume of sulfuric acid into 14 divided by mass of the organic compound into 100. So this simple formula we will be using to find the percentage, the mass percentage of nitrogen by using which method? Geldahl method, isn't it? Now the next method, let's see the next method, isn't it? I have enough experience to teach you, buddy. So next method is 2-mass method, isn't it? 2-mass method, in 2-mass method the organic compound CX, HY, NZ, whatever organic compound that you have, would be heated by or heated using copper oxide in 2-mass method. You see, this is the topic which we might have ignored in 11th. So I sincerely urge you all to concentrate on this topic. This is very important topic. So when this is heated with copper oxide, the entire nitrogen part is being converted into, this portion of nitrogen is converted into what? N2 gas. You can see that Z or Z moles of nitrogen is present. So I am balancing that by putting Z by 2 here, because you know Z by 2 into 2 is Z. So nitrogen balancing is going on. Alright. So this method is based on the measurement of what we do here. We measure the volume of N2 at STP. So, this whole process is based on measuring the volume of N2 at STP. So, now based on that we will end up with one formula which I will give you. Just substitute the given data in that formula to get your answer. Alright. So, I will give that formula. Now, this is not the time to derive these formulae. Now, I will give you the formula, try to memorize these formulae so that when question is repeated you can easily attempt, isn't it. Now, percentage of nitrogen over here is equal to 28 because N2 is obtained, the molar mass divided by 22,400 STP, the molar volume, into volume of N2, alright, divided by weight of the organic compound into 100. So, you guys have to remember this formula, right? You have to remember this formula. Take a screenshot otherwise. Alright, so you can see when I am substituting the given data over here, you guys can make out the percentage of nitrogen is given as how much? If the mass percentage of nitrogen is 46.8, so straight away I am substituting 46.8 here. 28 by 22,400 you need to simplify later. Volume of N2 at STP, you guys can see that volume of N2 at STP is given as 23.4 milliliter, right? So, you need to substitute in milliliter only, 23.4 milliliter. By weight of organic compound is given as X and you need to find the value of X only. So, you can see that the calculations would be simple for the reason that this value and this value is getting cancelled by 2. You can see this is 23.4 and this is 46.8, alright, and you have to calculate and get your answer. You can see that when you do the calculations you will get the value of X as 1 by 16, alright. Have you understood? Are you there? Are you following up? Okay, I hope, alright, you guys are following up very well, right? Now listen, the next question is number of peptide bonds in a tetrapeptide. See, amino acids are combined in a fixed ratio. You see, when you take amino acids, they are combining in a fixed ratio to give you what? These peptides. Now when we are talking about the conversion of what you call the amino acids into peptides, which you study usually biomolecules, right? Amino acids, one amino acids carboxylic acids, the other amino acids amino group would mutually combine with each other. You guys can make out here, you can see that H and OH will be lost, and the linkage which is established here, the linkage you can see which is established over here is what you call as peptide bond. So, this peptide bond has got some significance for the reason you guys can see that there is sufficient amount of resonance which is being taking place between the NH and C double bond. You can see there is a resonance taking place, because of which you say that this bond is stronger, that is the bond energy is higher, and you also say that there is restricted rotation around this peptide bond. That bond cannot be freely rotated, so no conformational isomerism, and you know bond energy is high because there is a resonance going on and bond length is low. So, any question might be asked related to the peptide bond. Peptide bonds are stronger, peptide bonds are shorter, peptide bonds are stable because of the resonance, peptide bonds do not freely rotate because of the resonance. So, any question could be asked from the peptide bond, and you can see if you are taking two amino acids 1 and 2, they will combine to give you one peptide bond. So, 2 amino acids, 1 peptide bond, 3 amino acids, 2 peptide bonds. You can see here tetrapeptide. So, 4 amino acids will combine through what? 3 peptide bonds, right? So, number of peptide bonds would always be less than by 1 unit than the amino acids. 4 amino acids tetrapeptide, so number of peptide bonds would be 3. If 3 amino acids are combining, tripeptide, number of peptide bonds would be 2. 2 amino acids are combining, dipeptide, number of peptide is 1. So, likewise you have to decide here, alright. You can see the next question, right, little bit lengthy in assessing the options, but you all know that unless you assess the options carefully, it will be difficult for you to understand the questions. You can see you have to straight away strike on what is given: absorption wavelength, lambda absorbed in the visible region for different complexes of the cobalt. You see, when we talk about CO plus 3, alright, you can see in almost all the cases the coordination number is given as how much? 6. Number of ligands attached 3 into 2, because ethylene diamine is a bidentate ligand, and 6 water molecules are present. Now, when 6 ligands are approaching the central metal atom, you know that the orbitals would split, the d orbitals of the cobalt would split into T2G and Eg. This we have studied in crystal field splitting theory, isn't it, or crystal field theory. So, the gap between these orbitals, which we refer as delta naught, that is crystal field splitting energy, depends upon two factors. One is charge and size of the central metal atom, second is strength of the ligand, isn't it. Now, if you take a strong ligand, you can see that here, when strong field ligand is present, then in that case the energy gap between these two would be high. The gap between the T2G and Eg orbitals would be greater, isn't it. So, when the gap between these two is greater, the the energy absorbed would be greater. Energy absorbed is greater. So, strong field ligand, energy absorbed is greater, wavelength will be lesser. Always remember this. What did I say? Strong ligand, you say that energy absorbed is high, energy is high, because we know E equal to Hc by lambda, energy is high means lambda is absorbed is low. So, remember this relationship, alright. So, strong field ligand, you know, when you have studied the spectrochemical series, you have understood that the bidentate chelating ligands such as ethylene diamine is stronger than ammonia, which is stronger than water. So, you can see that strong field ligand, lambda absorbed is lowest. So, you can see what is asked, correct increasing order. That means what? Starting from the strong field ligand. Strong field ligand has lowest, weak field ligand has highest wavelength, isn't it? You can see what is asked, wavelength. So, you please see whether wavelength is asked or energy is asked. Anish, are you understanding what I am saying? So, you all have made a mistake, buddy. Yes. Ravindra, can you hear me? Bhargav, are you there? Yes, you guys are understanding, isn't it? See, there should not be any scope of error, Vasu. The answer is not A, Ushasri. How could it be A? Could you please justify that? So, simply remember this logic: strong ligand, less lambda absorbed, more lambda emitted. Ulta, exactly opposite. Remember this. Don't get confused, buddies. Okay. Those who want these supplementary and all that, this is not the platform, isn't it, right? You please take the NCERT or you buy a guide for yourself and concentrate on that instead of wasting your time on YouTube, right? You have to read and interpret your answers if you are seriously preparing for the board examination. Alright, and these classes are clearly meant for those who are seriously eyeing on the NEET examination, which is written by 25 lakh odd people. Alright, so please concentrate. These questions are important, and the next question is on lanthanoid and actinoid contraction. You all know, whether you study lanthanoid or actinoid, the contraction concept is similar. Let me explain that for you. If you take lanthanoid or actinoid, the nucleus will have more force of attraction on the valence shell, isn't it, which happens to be n equal to 6. What did I say? The nucleus will have more force of attraction on the valence shell. If it is lanthanoid, the valence shell is 6. If it is actinoid, the valence shell is 7. Why it has more attraction force on the valence shell is because of poor shielding of the 4f orbital which is present within. Let me show you 4f orbital which is present over here. You know, when you write the electronic configuration, general electronic configuration of these elements, it is ns, n minus 1d and n minus 2f. Now, since 4f show very poor shielding effect, you know, you have studied shielding effect, isn't it? This nucleus will attract the valence shell closer. So, when it is attracting it towards itself, the size gets decreased. As the proton is added into this, that means when atomic number is increased, the size of the atom gradually decreases. This is what is seen from lanthanum to lutetium or actinium to lawrencium. This happens in lanthanoids as well as actinoids. That is the reason why you call it as lanthanoid contraction or actinoid contraction, isn't it, buddies? Alright. So, because of this lanthanoid contraction, please understand, lanthanoid contraction, the size of the lanthanoids and actinoids would gradually decrease as atomic number increase. This is point number 1. Remember all the points, important points. Due to lanthanoid contraction or actinoid contraction, the metal cations are smaller. Since metal cations are smaller, their hydroxides and oxides are more covalent. Understand that their hydroxides and oxides are usually covalent. So, these are very important points. Since they are covalent, they are considered to be less basic. So, these are very important points associated with lanthanoid contraction or actinoid contraction. Alright, Anish? Okay. So, let us concentrate, buddy. This is meant for those who are interested. Alright. So, now this is what is going on. Now, listen, the lutetium, first of all, you should have the grip over the atomic numbers of the elements. You know that lutetium happens to be the last element of lanthanum series, lanthanum to lutetium, right? Lanthanum to lutetium. So, what is happening from lanthanum to lutetium? The size will decrease. If size is decreasing, they tend to become what? More covalent. You can see if it is more covalent, it will be less basic, not most basic. Lutetium smallest, because it is the last element of that series. So, smallest means what? Its oxides and hydroxides are more covalent. That means less basic. So, it is mentioned as what? Most basic, which happens to be what? The incorrect statement. Please read out the remaining statements, you will rather understand. Okay. Yes, it has got significant weightage, buddy. D and A block elements happens to be very important since the time the chapters are deleted, especially hydrogen, S block and reactions of P block, metallurgy. What is left out in inorganic chemistry? Hardly any chapter is left out. Very few chapters are left out. And the left out chapters are D and A block, coordination compounds, isn't it? Salt analysis, periodic properties and chemical bonding. Only 5 chapters are there. So, definitely the weightage will increase. Out of 15-16 questions, you can see that total number of questions are 50, out of which 15 to 16 questions are from inorganic chemistry and 15 to 16 questions will be asked from what? 5 chapters. That means every chapter will have 3-4 questions. Imran, deleted portion. 5 chapters only significantly present. So remember, emphasize on these chapters. Don't skip this topic especially. Now listen to the other thing. Actinoids are highly reactive metals, especially when finely divided. Nothing seems to be wrong with any of the statement except C. Okay. Number of hybrid orbitals, you can't expect anything easier than this. See, what will happen usually is that the previous question will take more time than this question. So please focus on the questions which could be easy. Let me tell you, 60 to 70% of the questions would be easy in NEET. So number of hybrid orbitals is asked. And if you take benzene, what is the answer, buddy? Yes, brilliant. 3 into 6, super fast, Anish. So total number of carbon atoms are 6, and each carbon atoms sp2 hybridized, and there would be 3 sp2 orbitals, sum of the powers of the orbitals. So 6 carbons, 3 orbitals on each. So total number of hybrid orbitals is, alright, 18. You got it right. Chalo, next question dekhte hain. It's again biomolecules. You have been ignoring, isn't it? Jimmy, Imran, could you please tell me what could be the answer to this question? For this you should have an idea about, please listen to me, the structures. So in your NCERT or Board of Intermediate textbooks, in the starting pages, some of the amino acid structures are given. Before you go to the examination hall, Anish, I suggest you to look into those structure once. Frequently asked compounds are these. Okay, you can see which of the following is having heterocyclic ring. This you can do by elimination method. Right? Glutamic acid, right? It's an amino acid which is said to be what you call having. It is called an acid because it is having what? A COOH group in the side chain. So this doesn't have any heterocyclic. That means ring with any hetero element in it. So that could not be the right answer. Phenylalanine, you know that if you take alanine, it's actually methyl amino acid. That means if you have CH3 here, it is called alanine. That's a brilliant score, Anish. Now phenylalanine means CH2 C6H5. These two does not have any heterocyclic ring present. Then we have to zero upon these two structures. Okay. Now, right, isopropyl group is present at the side chain. And lastly, tryptophan. Let me draw that structure for you. All right. So remembering these structures is very important for you all. You have no other way than remembering these structures, buddies. So it has an heterocyclic ring present with it. So you have to remember, there is no other way. You guys can see that this heterocyclic ring, all right, heterocyclic ring is present in tryptophan. So tryptophan is the right answer to that question. I hope you will take the screenshot of these structures, or you will take the support of the Google to remember these structures. There is no other way out. All right, you have to remember, right? So tryptophan is the right answer. You can get the answer by elimination method. At least if you remember two structures, you can work out on the other. Now you see, this is a complicated question which I have seen in NEET examination so far. Listen now. Which 3D element has the greater tendency to convert from +3 to +2? Alright. Whenever any element is converting from +2 to +3 or +3 to +2, you will attribute that to the electronic configuration. For example, if you take Cu +2, it is 3D 9. Cu +1 is 3D 10. You will say Cu +1 is more stable. But in water, Cu plus 2 is more stable because of hydration. Whereas here you can see that it has more tendency to convert from plus 3 to plus 2. That means what? The tendency of a particular element, whatever it is more to convert into plus 2. That means its reduction potential value is high. This reduction potential value is high. This is a purely theoretical question, right? Reduction potential value should be high. It is not purely based on the stability, Ashley, Anish. Okay, it is not based on the stability buddy, because if you look at the stability of the element plus 3 to plus 2, you need to pick something which is stable at plus 2 oxidation state. This cannot be predicted only on the basis of electronic configuration. This has to be predicted on the basis of what? Standard reduction potential. It's been noticed that the cobalt has more reduction potential value to convert into plus 2. There are multiple reasons associated. Let me explain this for you. Number one, it is you can see that plus 3 and plus 2, if you are writing electronic configuration, when you are writing, it is not going to fetch you anything. For example, if you write CO plus 2, it is 3d7. If you write CO plus 3, it is 3d6. Both are not stable, only 3d5 is stable, which is nothing but Fe plus 3, isn't it? So the answer is only the reduction potential value. It's being noticed that the E0 value for the cobalt to convert into plus 2 is greater. You cannot just like that answer unless you know it. Alright, so when you are asked such type of questions which are purely textual, you can't help it, you should know them, isn't it, Anish? Okay, so let's see the next question, which is from the salt analysis, the test for the cations. Now we know in cations, every group is given one group reagent. First group reagent is dilute HCl, which is used to confirm the presence of Pb, Ag and mercury in plus 1 oxidation state. Second group reagent is H2S plus dilute HCl. Third group reagent we have, likewise fourth group reagent. Likewise, based on those group reagents only, you have to understand which cation is present in which group. Now you tell me Pb plus 2 belongs to which group? First group. What is the reagent which is used for the first group? Dilute HCl, isn't it? So this is matching with this. Go on. You know, carbonates are used to precipitate the fourth group cation, strontium, calcium, alright, calcium, strontium and barium. So you have B matching with 4, right? A matching with 1, B matching with 4, isn't it? Now you have H2S, alright, is for this, and you all know aluminum hydroxide will form a white gel like substance. So here PbCl2 is the precipitate formed, here aluminum hydroxide white gel is formed, over here manganese sulfide, alright. So this is white crystalline insoluble in water, this is white gel, manganese sulfide is buff or pink color, and over here SrCO3, a white PPT is formed, right. So depending upon the reagent, the precipitate can be picked up, alright. So accordingly, I believe this should be the right answer. What do you all say? Yes, isn't it? Next, which among the following compounds will be more reactive for reaction? You know that when reactions are being spoken about, Anish, let's concentrate on this. Also the remaining student, I suggest you, Ashley, and who else is concentrating here and giving the quick answers? Rebecca, Anish, like in the last class I could see that some of you are giving what you call brilliant answers. So let's concentrate. Could you please tell me what could be the answer for this? Now this is purely based on if it is alkyl halide, remember the reaction would be nucleophilic substitution. Alright, so when we talk about nucleophilic substitution, this is secondary, this is allylic, adjacent to the double bond is called allylic, this is tertiary cum allylic, you can see carbocation would be very stable, this is tertiary. You know, when we talk about the stability of the carbocation, the highest reactive is being allylic 3 degree, alright. Then comes allylic, then is 3 degree and then is your 2 degree. So this is how it goes, alright. Next, as I could see that this compound is being mentioned and maybe the functional isomer to that particular compound is being asked. A question was incomplete. So I think functional isomer of this amine, which is primary amine, is asked as a question. What are the functional isomers of the primary amine? Secondary and tertiary. If this is the question, you can see this is primary, this is also primary, this is primary and this is secondary, alright. So primary and secondary are, so if that is the question, because I saw the answer and because that was missing, so I thought it goes like this, the question is incomplete, alright. Chalo, next question. Please see the question here. This is related to the hydrolysis, right? Hydrolysis reaction with water. Please understand the difference between hydrolysis and hydration. Hydrolysis means reacting with water to produce some product. Hydration means it is not reacting, it is just watching. If you are watching the cricket match, it is hydration. If you are playing the cricket match, it is hydrolysis. Please don't get confused. Watching the cricket is hydration. Playing the cricket is hydrolysis. Here, fluorine is a strong oxidizing agent reacting with water to give you oxygen gas. Alright, so what is happening here? Fluorine oxidizes water because you know water has oxygen in -2 oxidation state and fluorine is a strong oxidizing agent. It has more tendency to take electron from the other. It is electronegative element. You know, when it comes to the oxidizing power, it is directly proportional to electronegativity. In that case, which one has highest electronegativity among all the halogens? You all know the reason, isn't it? Fluorine is the strongest oxidizing agent. So what it is doing? It is oxidizing this oxygen from water to O2. Alright. So in that process, that itself gets reduced. So it is giving rise to oxygen, makes sense. However, chlorine is not that strong acid, strong oxidizing agent. Therefore, what is happening with chlorine, that it is forming HCl and HOCl, hypohalous acid. It is not as strong as what you call fluorine. So statement 1 is correct. Statement 1 is correct. But when it comes to statement 2, oxidizing power of halogen increases down the group, that is wrong. Decreases down the group. So statement 1 is correct, statement 2 is false. Alright, hope you are following. See, that's a brilliant answer, buddy. Excellent. Rebecca, good answer. What is the reagent? Very popular, isn't it? What is the product which is obtained? Cis. That means syn addition. That means Lindlar catalyst. Alright. Now what do you call this? If I am carrying out anti-addition, when I am carrying out what you call anti-addition, what do you get? Trans. Anti gives rise to trans, and that's what you call as Birch reduction, right? So this is Birch reduction. Sodium in liquid ammonia is being used. So for trans, sodium in SJE 24 question, brilliant, and was last year NEET question. So you can see these questions are only repeated, buddy. There is nothing new which is being seen nowadays. If you look at last 5-6 years JEE and NEET papers, you will be getting the entire paper as it is, believe me. So right answer for this question, for cis it is Lindlar catalyst, for trans Birch reduction, please understand this. Yeah, look at this question. It's from solutions, it's on Van 't Hoff factor and colligative properties, and it is asked about the largest boiling point. You must write the elevation of the boiling point equation. What is that? TB minus TB naught. That means pure water's boiling point will increase to TB when I add a non-volatile solute to the volatile solvent. This is what you have studied as colligative properties or Raoult's law. Now, since some of them are electrolyte type, you will put Van 't Hoff factor I. Now, you can see that when we are comparing here the boiling point of different solution, you can see these two has to be compared, these two has to be interrelated, because remaining things are common. Boiling point of pure water is 373 Kelvin, this value is constant and this is given as same, alright, constant. Now, TB is dependent on Van 't Hoff factor. TB, boiling point, what is TB buddy? Boiling point of solution is dependent on Van 't Hoff factor. What is the answer? Yes, Anish, you don't require any inputs, it seems that you are giving super fast answer, that too accurate, brilliant, good going. But I think little haste, little hurriedness might tamper your chances, so please be optimistic and optimum velocity. Yes, Ravindra, you said, let's check. And you know, Van 't Hoff factor is nothing but the number of ions produced by 1 mole of the salt. 1 mole of the salt giving rise to how many ions? You can see 1 potassium, 1 I value equal to 2. And this is non-electrolytic type, I value equal to 1. It doesn't dissociate or associate. Here you can see 2 aluminum and 3 sulfates are formed. So, I equal to 5. And over here 2 potassium and 1 sulfate is formed. So, I equal to 3. You can notice here one thing, more the value of I, more the value of I, more is said to be the boiling point. So, largest boiling point is for that electrolyte which has, yes, more number of ions. So, I equal to 5, Anish gave the right answer, Ashley gave the right answer, Usha Sri, I think for the previous question you said it. Yeah, could you please mention expected to be the most stable one? Come on, I am leaving this for you for a while. I don't want to answer that. Chalo, I will wait for your answers. How would you predict the stability of a carbocation? It's called as uranium ion, isn't it? This is called as sigma complex uranium ion, which you will see in electrophilic substitution, or also called as Wieland intermediate. 3 names. Come on, speak out. What's the answer? Which one is orthopara is stable? Is it so? For NO2, do you think orthopara is stable, Ashley? NO2 is electron withdrawing group, isn't it? Anish, bete, kya baat hai? Listen now, whenever you are given a call, listen now, let me explain. That's a good answer. Listen, how does it give? It takes electrons like this. Alright, you can see there is a positive charge on NO2, which is a very strong electron withdrawing group. It will cry foul. It is taking electron, the pain has increased. It is suffering with more pain, but it already has a positive charge. You are taking, you are pulling the electron from it. Quite unstable. Over here also quite unstable. So, these two are ruled out. Now, check these two. So, what is happening here? You can see there is a plus here. You can see the electrons going out here. So, this you will get plus. Electrons are going in here, minus. So, you all know you can't afford to put a positive charge on the carbon which is attached to the electron withdrawing group. So, out of these two, very good. Brilliant. Excellent. Find the ratio of shortest wavelength. So, this is somewhere they might what you call test your acute thinking abilities or presence of mind. You see, they said shortest wavelength. Shortest wavelength means what? Anish, you solved it also. Good. Ashley talks. Brilliant. What is shortest wavelength? What's the value of N2 corresponds to? Because you can see this question is based on the Rydberg equation. For shortest wavelength, N2 will always be infinite. Why N2 is infinite? Because shortest wavelength means highest energy transition. So, this is otherwise mentioned as highest energy transition. That means electron is making a transition from some infinite energy level to first. So, we do not know from where it is jumping, but it is what you call Lyman series, it is jumping onto 1. If it is Balmer series, it is jumping onto 2. And you know how to find out the corresponding wavelength. RH Z square, do not try to put up these values, right, they get cancelled. 1 by 1 square minus 1 by infinite square, lambda of Balmer RHZ square into 1 by 2 square minus 1 by infinite square. You know that 1 by infinite is 0. So, this term disappeared. This when you divide, this gets cancelled and the ratio will be simply 1:4. What an answer. Brilliant. Excellent. Kya baat hai. Theoretical question again on the nomenclature. Rebecca, could you please tell me what is UNU? Just a sample sake, because it is difficult for you to understand the IUPAC official names. Could you please tell me? What is UNU? Why don't you practice these namings, right? No idea. You need to practice once Ashley talks. Un, right, means one. Because you know, when chemistry was under study, English was not there. Chemistry is most ancient subject, right? So, when English was not there, most of the terminology was assigned in Greek and Latin. That is the reason why you would see the names are given in Greek and Latin, not in English. This is one more headache what we have, isn't it? We have to remember chemistry reactions, we have to remember the Greek and Latin also. So, that is the reason why we find at times tricky, and in that theoretical questions are asked. You can't exactly predict, but I suggest you in the periodic properties textbook, the short notations are given, at least for the elements whose atomic numbers are above 100. So, my suggestion to you, just go through Rebecca, alright. Un means 1, nil means 0, nil is 0, isn't it? Unniyam, alright. So, 101, un, u un, n nil, again u un, right? Un nil quadium, 4, quad, yes, it was asked 19 NEET maybe. Un nil septium, 109, un nil ennium, so this is how you will remember. Is it okay? Ravindra? So, this is Mendelevium, Rutherfordium, Bohrium. This is not correctly. Incorrect match is being asked. Yes, yes, please refer to NCERT just once. Just once I wish you all refer to NCERT. Option D, that's a brilliant answer. Because the name is Rongenium. Rongenium is the name of that compound. You see, we can't help it, you have to just remember, right? So, it is difficult, I understand, but you have to somehow manage, alright. The correct bond order of the following species, easy, just listen certain things related to this, alright. So, take this species, I will give you the reference, I think you can see O2, O2 minus 1, O2 minus 2, O2 plus 1, O2 plus 2. Listen to me. When you are given this species, there is a very easy method, isn't it? Total number of electrons here are 14. You can see electrons number. And isoelectronic species will have same molecular orbital theory. Isoelectronic means which are having same electrons. You can see 14 electron species like N2, Cn minus, NO plus, alright, CO, O2 plus 2, all this will have similar molecular orbital theory. That means bond order equal to 3 diamagnetic, alright. And you know oxygen is 2 paramagnetic. This is between 3 and 2, 2.5, and fractional means paramagnetic. This is 18 means fluorine, and you know there is one bond between two fluorine atoms, so bond order is equal to 1. So between 2 and 1 it is 1.5, hence it is paramagnetic, and this is diamagnetic. So you should remember this actually. I don't really know about that. I have absolutely no clue. I think you are having perfect understanding in the subjects which are going on, Rajalakshmi. Are you following up thoroughly? I think I have seen you in your in my previous sessions also. Your understanding, isn't it, Rajalakshmi? So let's concentrate on physics and chemistry because you know they are scoring. Now listen, have you understood this? So we are talking about the bond order. You guys can see more the positive charge, usually more is the bond order. So more the positive charge, O2 plus 2, after that O2 plus 1, and then O2 minus 2. Majority of you have given the answers, Shubham. Good. I just wanted to cross check. Could you please tell me what's the answer for this? I'll wait. Acha, you made mnemonics, bete, Anish. That's brilliant. See, you are good at self preparation, it seems. That's how it works. Could you please tell me the answer for this? I am waiting. Shubham bete. Anyone? Rebecca? Ravindra? I need not ask Anish because anyways he will give. Ask Anish. Shreyas? 1. Simple, isn't it? Noble gases have very low boiling point because of poor intermolecular forces. Finished. What to discuss in that? Intermolecular forces are weak. What do you call those forces as? What are they? The intermolecular forces between noble gases are referred as what? Dipole forces bolte hain kya? Teja? What do you call them? London forces or dispersion forces. Van der Waals forces nahi bolte hain beta. They are not van der Waals forces. Van der Waals forces means what? Dipole, dipole induced dipole, and London forces. All three put together van der Waals forces. Is this understood? Anish? All three are van der Waals actually. Is it understood? Yes, that's the reply. I hope you all have understood, isn't it? Okay. So the third one is called London forces or dispersion forces. So please take out NCERT textbook, first 2 pages of gaseous states of matter chapter. It's not there in your syllabus too. Alright. Chalo. question is from physical chemistry. Teja, come on, let's concentrate and let's what you call let the others concentrate. All right, there are students who are doing it very sincerely, and these sessions are really helpful for them. I wish you all stay tuned, concentrated, focused. All right. Now listen, we are talking about what you call 8 mole of a gas AB3 are introduced into 1 decimeter cube, 1 liter. Now, I'll tell you how simply you can solve these questions. Problems will take some time. At equilibrium, 2 mole of A2 are present. You can see that you have taken initially 8 mole. Listen to me please, 8 mole. If you are weak at numerical solving, please listen to me. Okay? Now, you should not take time. Listen now, please be careful. You can see how many moles of A2 is formed? 2 moles. You can write this in terms of X at equilibrium. This is initial case. Initially, these are the mole that are present. At equilibrium, what is happening? Some X moles have reacted from AB3. Let's assume some X moles have reacted. So, how many will be left out? 8 minus X. For X moles of AB3 lost, 2:1 is the ratio. If this is losing 2 moles, this has to form or gain 1 mole. Ratio is 2:1. If this loses X, this would be half of X by 2. If this is 2 moles, this is 3 moles. You can see the ratio is 2:3. If this loses X moles, this will be 3x by 2. So, this notation you must be good at writing. If you are good at writing this, it will be easy for you. Chalo. Now, you can see what is given in the question, you please check. You can see that you are given 2 moles of A2, 2 moles of A2. You can see the number of moles of A2 at equilibrium is given as 2. That is all. So, X value is 4, finished. You got X. After getting the value of X, you know how to substitute and get your answer. Kc is asked, which is equal to concentration of A2 into concentration of B2 whole cube divided by concentration of AB3 whole square. Just straight away substitute the values. X by 2, that is 4 by 2, 3x by 2, that is 3 into 4 by 2, 3 into 4 by 2 is 6, divided by 8 minus x, that is 8 minus 4, 4 whole square. That is all. Simple. You should not take much time, isn't it? Simple. Just look at the way we solved. It's as simple as that. Calculations will not be hectic, don't worry. Van 't Hoff factor again, important. Oh, you took 1 mole. Acha, Ravindra Sai, you did it? Acha, you got it? Brilliant. Van 't Hoff factor of Hg2Cl. See, most of the students make a fundamental mistake by dissociating it like 2 moles or Hg plus 2, something like this they will write. They forget the fact that this Hg2, listen to me, very important question. Very important question, buddies. Listen please. Hg2Cl2 will dissociate into Hg2 plus 2 plus 2Cl minus. Don't make a mistake by dissociating it like that. Please see carefully. It is mercurous ion dimer because it has an odd electron, isn't it? So, I will assume that the initial moles, please listen, initial moles, same thing which I did in the previous question. Some A moles of this thing is present, right? These two are 0. Finally, some A into 1 minus alpha has gone. This is A alpha and this is 2A alpha. Listen to me if you have not studied this topic before. Please listen. So, this is how we should write the split. 1 mole gives rise to 1 mole, A alpha gives rise to A alpha. 1 mole gives rise to 2 moles, A alpha gives rise to 2A alpha. Now, after writing that, Van 't Hoff factor I equal to equilibrium moles A into 1 minus alpha plus A alpha plus 2A alpha equilibrium moles by initial moles. This is the formula for Van 't Hoff fact. What do you get? A into 1 plus 2 alpha by A. So, this value is turning out to be 1 plus 2 alpha. So, I is equal to 1 plus 2 alpha. I will give you a simple formula. Remember, I is always equal to 1 plus n minus 1 into alpha. Remember this formula, always, where n is number of ions, that is all, where n is number of ions. Please make a note of this formula instead of deriving this all the time. You can see number of ions here formed are 3, 1 plus 2. So, you can see what you get, 1 plus 3 minus 1 into alpha, 1 plus 2 alpha. That is it. Remember this formula now onwards, do not derive the whole thing. Isn't it, Ashley, Ravindra Sai? So, I is equal to, when you substitute the value 1 plus 2 into degree of dissociation is given as 0.8, 80%. That is what we did know. So, this value is turning out to be how much? 2.6. Yes, Anish? Yes, 1 by same thing, right? I wanted to just derive it for the sake of others. The same thing, I minus 1 by n minus 1. Alpha kidhar hai? Acha, alpha equal to. Yes. Brilliant, yes, Anish. Just wanted to derive this formula for everybody. Alright. 13th group element with least melting point. See, listen, whenever we talk about the melting point, remember that this is directly proportional to charge, inversely proportional to size. So, always remember, smaller has smaller metal. Remember this, because every time same question will not be asked, has more melting point. So, usually the first element of the metallic series will have more melting points. As we go down the group, the melting point decreases, because as it grows bigger, the intermolecular forces decreases because of size increase. Now, when we talk about gallium in particular, yes, it is gallium. What is the reason behind it? Is because it exists as a dimer. It is not existing as a polymeric unit, it is existing as a dimer. If two species are together, it cannot hold the other molecule. So, it is easy to separate these units. So, the reason is low boiling, it is not about boiling point, it is about melting point. So, reason is existence of dimer, right. Now, let us see the next question, buddies. Alright. What is this question? Yeah. Yes, A plus B giving rise to this thing. What is asked? Acha, products and all that. Yes, you know that, right. The first reaction is Williams and ether synthesis. And second reaction is pretty much known. You cannot break this bond because there is a resonance. So, you need to break that bond only. I will write it here separately. You can't break this bond because there is a resonance. You can't break this. You can break however this. So, you will get C and D as phenol and methyl iodide. This is a very important reaction, frequently seen. We have discussed in the previous sessions also. Now, in order to prepare this substance, Williams and ether synthesis clearly says that you need to take phenoxide and methyl iodide through a SN2 pathway, Williams and ether synthesis. Williams and ether synthesis says that the reaction follow SN2 pathway. SN2 requires lower steric repulsions. SN2 requires lower steric repulsion, which is there with methyl iodide because 3 hydrogens are present. So, this should be the right answer, right. What is the answer, buddy? 2. Yes, perfectly matching. Hope you understood, isn't it? Yes, B. Anisole. Yes, good. You see, you got 2 oxygens here by virtue of oxidation of this compound, which doesn't have any unsaturation. For 4 carbon, there are 10 means this is alcohol, saturated alcohol. So, if you are converting the saturated alcohol into the compound which is having, you can see 1 pi bond 48H means 1 pi bond is there and 2 oxygens. That means this is carboxylic acid. and carboxylic acid are obtained when you take primary alcohol. You know, this is primary, this is primary. So, right answer should be A and C. Yes. It's a beautiful question, isn't it? Simple and sweet. What do you all say? Next question, concentration of Ag plus in a saturated solution. This is so nicely asked, let me tell you. They did not give you the solubility, they gave you the concentration of Ag plus so that you just fumble initially. You can see when they gave you silver oxalate, it dissociates into what? 2Ag plus C2O4 minus 2, and you have been asked to find out the solubility product, isn't it? Now listen all of you, solubility product. Now when I am writing or assuming the solubility as S, you will get 2S and S mole per liter of these two ions, isn't it, right? Not tough, easy, interesting. You can see that you will be getting 2S moles of silver ion. It's a beautiful question, I will tell you why. Because you see, you are not given solubility here, you are given concentration of Ag plus, that's the beauty. So it is 2S which is given to us. It is not S. Most of the people have mistaken it as S and they have tried to solve this question. So solubility is this. It's not 2S. So this is where you need to be careful. That's the problem. You need to be careful there. Small mistake will take you to the wrong answer. The other answer also will be there. So you know, for this Ksp is equal to what? Concentration of Ag plus whole square into concentration of oxalate. So 2S whole square into S, that is 4S cube. So you need to substitute the S value as, luckily, 4 into 1.1 into 10 power minus 4. So this should be the right answer, whatever it is. Yes, small misconception might take you somewhere. This is another beautiful question, buddy. Can anyone answer this question? Ashley, Ravindra Sai, could you please? Vandana, could you please answer this? Shreyas, Shubham bete. Rate constant is not influenced by the catalyst. A. Is it A? One is correct. No, that's wrong. Listen. Now what is happening here? Listen to me please. This is very important. See how it goes, you know, while I am on my way to the studio, I was always following the longer path. But somebody guided me that go by this route, it will reduce the distance by 2 kilometers. That means that person is acting as a catalyst. So what he is doing is that he is providing me with an alternate route in which my activation energy is decreased by some units. So obvious that the rate constant is influenced. Who says no? That's wrong, Anish. Have you understood? Yes. So it influences the rate constant. Got it, buddies? This is very important. This is so brilliant. Is this clear now? Yes. Actually, you should know that it provides an alternate path with lesser activation energy or more K. That's the point. See, people commit a mistake here. If activation energy is changed, decreased, so obviously the K would increase. And that reaction actually would have been a first order reaction if that is not done in presence of I minus. If it undergo room temperature decomposition, this is another bouncer, another googly. Room temperature, it is first order. Normal decomposition of H2O2, but it is, you can say, iodide is involved in the reaction. So rate depends upon the concentration of OH minus also. So it's a second order reaction. I had to thoroughly check before. Second order reaction. So both are wrong. Alright, next. In the following reaction, what is the product C? Can anyone tell me? First you will get cyanohydrin, isn't it? First you will be getting cyanohydrin, alright. Then hydrolysis of cyanide, because you see concentrated sulfuric acid will certainly have some what you call water which will convert CN into COOH, and finally that loses water and give you the conjugated system which is resonance stable. So right answer should be Bombay. Good, well done. Theoretical question, can anyone answer this? PYQ 23, yes buddy. Could you please answer this question? SiCl4. How would you tell me whether a particular compound undergo hydrolysis or not? Easy thing, because majority of the questions on that. Listen now, if the central atom has empty orbital, it undergo hydrolysis. CCl4, carbon does not have any 2d orbital. Na? That's the reason why CCl4 does not undergo hydrolysis. SiCl4 undergo hydrolysis, isn't it? SiOH taken 4 plus 4HCl. So easily hydrolyzed, correct statement A is there, but unfortunately A is there. And GeX4, you know that higher elements will be stable as higher oxidation state, lower elements will be stable as lower oxidation state, inert pair effect. B looks to be stable, correct. SNF4 is ionic in nature, yes, plus 4 oxidation state. PbF4 does not exist as such, because Pb plus 4 does not exist. For the reason, in the sense that Pb plus 4, quickly want to convert into Pb plus 2 due to inert pair effect, is covalent in nature. That's a wrong statement, because Pb plus 4 does not let, yes, ionic is the right answer. So I think ABC should be the right answer. That's brilliant. Next, who else will give the answer to this question? Thermochemistry and thermodynamics. Come on, speak out. H2SO4 plus NaOH. Listen to me carefully. These questions you might have not attempted before. Na2SO4 plus 2H2O. Listen to me, buddies. Be careful while solving these questions. You guys are giving the answer so fast, man. This is 0.2 mole. Please listen to me. And this is also 0.2 mole. Alright. So you need to first balance the equation. Inert pair effect. Yes, correct. 2 moles of H2O. See, when you write the reaction between the H plus and OH minus to give you 1 mole of water. For 1 mole of water, the heat released is in kilojoule, no? 57.2 kilojoule. But here the amount of what you call H2SO4 or this thing NaOH consumed is 0.2. For 0.2 mole, how much heat would be released? This is the point of concern. That is your answer, isn't it? C, is it C? No, I don't think so. 57.2 into 0.2 would be around 11.6, I think, isn't it? Yes, it is 11.6. All right. Hope you understood what you all say. Okay. So that's all for this session, buddies. Keep watching and thank you. See you in the next session. Good luck.